All right, welcome back to the final talk on the tech track of 2021 for Datanova. And so this one's going to be a strong finisher for us because this is Joel Edwards from Simon Data talking about this extreme customization that they've done at Simon Data to basically extend out security events as well as various other aspects of the SPI, which is the service provider interface that is extensible in the Trino architecture so that you can add either security or other type of plugins such as connectors if you're trying to connect to a different data source. And so he talks specifically about why they chose Starburst in particular, why they wanted to basically based off the Trino architecture, but then chose Starburst as well to add on a lot of the extra features that they were looking for like resource customization, things like that. So let's take a look into this talk. I think you'll learn a lot from this, and ultimately this had an open piece of code that got open sourced, and so he will be pointing you to his open source code that is free for use for anybody. So really excited for you all to hear about this, and take it away, Joel.
Thank you, Brian. So I am here representing Simon Data, and I will be talking about critical customizations for Trino. Before we get started, I'd like to step through a few bits of conference etiquette. This is for me. First, no sarcasm, no memes, and no Monty Python references. That's probably the most important. Do I agree to this? Sure. On with the intro. So first, who are we? So my name is Joel Edwards, and I am a software systems engineer at Simon Data. So what does Simon Data do? We are a customer data platform, and we represent each of our clients' data, their customer data sets that represent their customers, in a unified form that allows us to build personalized cross-channel journeys. Those channels being channels of communication that permit us to both receive and send engagement data to their customers, our clients' customers. And we have beautiful and intuitive campaign and segment builders that empower our clients to build those engagements within our platform. So where does Trino fit in? Right about here. So it's primarily used as a mechanism for transforming inbound client data, basically performing large ETL operations that take a very long time, converting their incoming data sets into a common format we can use to power our engagements downstream. We also use it for batch lookup operations, which are relatively fast, metadata fetch operations as part of the user interface or other backend infrastructure. Those are very fast operations. Reporting, ETL, so internal analysis of the data that flows through our system or our costs. And those are sort of mid-duration queries. And then finally for ad hoc queries, which have varied lengths, durations, complexity. And finally, the last bit of the interrogation, what is your reason for using Starburst, or selecting Starburst? So when we look at Trino itself, a vanilla Trino setup and its management is pretty involved. So the biggest issues we observed while trying to do this was handling coordinator failover. So if we had a coordinator node drop, does it get automatically replaced? How do you ensure that? How do you monitor its health and then bring it back? How do you monitor worker health and replace them if they drop out? And then how do you deal with draining a worker or the workers that have been assigned queries, are ready for removal, but making sure that they continue the work that they have done until it's time to decommission them? And that's a lot of effort we didn't want to put forth ourselves. And that's where Starburst came in. Other services we evaluated and or used have given us limited or no ability to control query concurrency. It's the total number of queries running in the system at the same time. control over resource groups, that is, tuning an individual cluster's subgrouping of queries, access to the service provider interface, that is the ability to write custom extensions to Trino itself, and the release frequency, which tends to trail the open source Trino releases by a fair amount. With Starburst, we get self-healing clusters. They take care of coordinator and worker failover, as well as health monitoring. They're a lead contributor to the Trino project. They provide support if you have the Enterprise plan, which we do. We also have full access to configuration and full access to the SPI, that service provider interface, permitting us to perform some major customizations to our own clusters to make sure that they meet our full suite of requirements. And it's those last 2 points that I want to focus on in our technical section. So what are the customizations that we were able to benefit from when running Starburst? We were able to tune a single large cluster to handle all of our disparate workloads. So instead of running multiple clusters dedicated to different workloads, which can end up with additional overhead and cost, we were able to tune a single cluster to handle all of that and only have to monitor and work with that individual cluster, while still having the ability to replace it efficiently within a 5 to 10 minute window if need be. We were able to write an event plugin for real-time notifications on query events of interest. And we were able to write an Auth plugin, which permitted us to enforce our specific security requirements. So to start off, let's dive into resource groups and session property managers. This is the system customization that netted us so much benefit. Session property managers allow us to, for an incoming client that is a connector request to Trino, it allows us the ability to identify a property of that connection and for the duration of that session, apply some custom configuration parameter. These may be configuration parameters that were specified at a global level, but we then tune just for this session itself, for the duration of this session or individual query. And you can see in this example that we have a client tag we supply called slow. These are our longest running queries that get categorized this way. So we'll submit this, and then these session properties get automatically applied, permitting those queries to run longer and spill to disk so that we don't have to worry about them stomping on the memory requirements of shorter but higher memory footprint queries. And those can be those documents related to how to use session property managers are, of course, available on the Trino site. I figured I'd include those for your benefit if you have not evaluated those before. The next one that's fairly tightly coupled with the concept of the sessions is the resource groups. They use a similar syntax, but the resource groups refer to groups of queries being identified by that same selector concept. You can identify with a client tag or even potentially a username or query type, and then route them to the appropriate group for those identifiers. And that permits us to group like queries that have similar performance profiles, usage requirements, runtimes, and isolate them together. And it allows us to have each of those tied to the same queue as each other, but not interacting with the queue from other query groups. So let's look at a scenario. We actually had the situation where we had our metadata queries, those were supposed to be very high performance, low latency queries, getting queued behind our ETL or pipeline queries. So when we shared a common default queue for all our queries, a single resource group, our queries that were supposed to finish quickly would get stuck behind these ones that would take 15 minutes to complete, and as a result, no progress for a long time. Not a particularly friendly user experience if there is an async operation that is supposed to have a few seconds turnaround time. To address this, we defined isolated resource groups for those metadata queries, some specific to sysinfo and then the rest targeting users. Created a top-level metadata resource group, and then subgroups within there for the sysinfo and user groups. And by specifying a overall total and then subtotals within these groups, we're able to buy some leeway for even a single or a pair of highly active users to prevent them from completely saturating that queue or the concurrency for this particular resource group and allow others to continue. And also fully isolating them from our ETL queues and execution groups. So we use that concept, once again, of client tags that we submit with the query to identify which queries should be directed to which resource group. That made a huge difference in our performance of various components of the system. And there's the documentation for that feature. And finally, let's dive into the concept of the service provider interface and how we leverage that. So the service provider interface allows us to write plugins. Those are extensions to Trino's capabilities, and that encompasses connectors. Those are methods for communicating to databases or other data sources, such as S3. Types. New types can be added. Functions. User-defined functions that are available within your SQL. And then the two that we have actually implemented ourselves, system access control for custom authorization, and then event listener, which allows us to identify query events of interest and alert or respond to those in some way. So we'll start with the event listener plugin. The event listener plugin allows you to identify query creation, stage completion, or query completion events, and be notified exactly when those occur, and then perform some operation in response to those. System access control is a plugin that allows you to perform authorization operations. So there are multiple built-in implementations provided by Trino, and you can extend the interface in your own plugins to perform highly customized behaviors, or you can extend the existing implementations to override certain aspects of their behaviors. Each method within the system access control interface identifies an action based on its method, an identity, that is a principal or a user, and a resource that's being accessed or modified. We built a small custom framework to ease the writing of new plugins. The Trino plugins framework simplifies the addition of these new plugins. It centralizes and simplifies configuration. It centralizes the concept of logging and notifications. And it translates interfaces into more unified views. The two, in this case, that we've implemented. Those two being, once again, the event listener, which translates to the query events concept, and then the system access control, which translates to our Trino Auth concept internally. So the logger has the ability, this is built into our framework, this logger concept. It'll log to standard out and end up written out to the coordinator node. So you can pull those up on that system directly. Or you can configure a Slack webhook via environment variables or a config file and have it forward messages of interest out to Slack. And those are messages that may source from any one of the plugins, but it's automatically tied into the logger. And if you have Slack configured, error level logs just get forwarded, but you can override that behavior in the code or even via additional environment variables that we've provided. So let's first look at what we did with events. So our query events concept that extends the event listener plugin. It allows us to filter to query events of interest. So one of those three types that we described earlier. And then we can log out query details for those that we find interesting. and get immediate notifications on those events. So if we have a failure of a query, we can see that pop up in Slack, or we can go look at the history later on the coordinator and see what caused that, getting a stack trace on it. The query identifier, so we can go look up the actual query itself from the history. So here's an example of a query failure that occurred. And this one is actually related to permission issues. So this is an interesting tie-in between these two. But it failed auth against our custom authorization plugin. And then this query failure came in through the event listener plugin. And we can see here that we were denied permission to view a particular table. In this case, it was a select all query against a comments table. Another example here is queries directed to the slow lane. So when a query gets identified as a slow lane query and marked with that particular client tag, we can pick that information up in the event listener and send out a custom message for that as well. So this is the initiation of that event. It's been queued, and you can see that to the right. It's been queued within the slow lane. And I intended for this one to fail, and it did. So we get a second notification that comes out later saying the same slow lane query failed. So you can see intro events if you want. You could potentially log stage events, but this same message will also be written out to standard out, so you can pull it up that way if you prefer. But just one of the ways that we can get immediate notifications on when query events of interest occur. For Auth, we've written the Trino Auth implementation of system access control. Trino Auth is itself a trait/interface which supports writing sub-implementations. Namespaced auth is one such implementation, and you'll see that used later in some of the examples. But the idea is to translate the specialized methods that you see in the System Access Control plugin into a common DSL, authquery. And then you also have the ability to toggle auth for the entire system using a single configuration option within the Trino plugins framework. Here's an example of the Trino Auth plugin kicking out a notification to Slack. So because we have that common logging system within it, you have the ability to identify and forward out messages related to auth failures. This can be particularly meaningful for security when you want to have both an audit log, where this is pushed out into standard out, and immediate notification when an attempt was made to access a resource to which some identity should not have had access. Hopefully that doesn't happen, but it's better to be prepared. So we added this capability into Auth as well to notify us when a failure occurs. So the authquery concept, this may look a little unusual to the Java devs out there because the Trino plugins repository is actually a Scala project, which still targets the JVM and generates a fat jar that can be imported and provide multiple plugins via single import. But what you'll see here is that namespaced auth implementation I mentioned earlier that extends our own Trino Auth implementation of System Access Control. And then the authorize method that you override in your implementation of Trino Auth can perform pattern matching on the auth query and determine from there whether to allow or deny using functions of the same name, allow and deny, built into the auth query construct itself. You simply return those and it enforces that back up through system access control. So here are some examples of pattern matching against whether the principal or user happens to be root, and just permitting them to do whatever they wish. And then having a default of deny. If we don't match a pattern that is permitted, that becomes your default. The auth query concept represents three things, and you can see those in the pattern match, but these two are not identified in this particular example. Those three things being an identity, who you are, the resource, what you're trying to interact with, and an action. That is what you're trying to do with it, whether that is a read or write operation, perhaps a delete or an update of some sort. And all of those are represented within this DSL of sorts within authquery. So we can do a little bit more advanced work with this. We can match against an authquery with a user, capture the user, and inject that down into a conditional guard further on, including attaching that to this namespace. So in the case of namespace auth, there's a namespace attached on the initial implementation, and using the combination of the prefixed namespace and a suffixed user, a schema matching that format would then be allowed. But any other user trying to access another's or a namespace not identified would be disallowed. So that's an example of how you could do pattern matching and extract things such as who the user is and characteristics of the data they're accessing, such as the schema, to determine whether they're permitted to access it, and enforce that via Trino Auth. And that's it for what we did with it. But we've also made this available on GitHub. So you can pull a copy of Trino plugins, that Scala repo, and fork it, make changes to it, improve it, comment on it, send pull requests. No promises to work on those, but happy to receive, and do what you will with it. So fully open sourced and maintained as part of by the team here at Simon. So let's go ahead and summarize. First, Trino is amazing. Fantastic piece of technology. Really empowers us to build ETL pipelines that are fairly dynamically assembled and keep our stack working the way we need it to. Trino requires effort to run and really needs some customization to work to the best of its ability or its capabilities. And Starburst makes both of those things easy. We configured a single cluster for all of our workloads using resource groups and session customizations. We meet our security requirements through a custom auth plugin. We ensure visibility with a custom events plugin. And our plugins framework is open for forking and adaptation at will. So if you have any questions for me, I do have some contact info. Once again, I represent Simon Data. My name is Joel Edwards. My email address is jedwards@simondata.com. You can find me on GitHub under Joel Edwards or on LinkedIn under Bazuli. Thank you for taking time to listen to me.
Awesome, Joel. Thank you so much for that talk. And I'm sure everybody learned a lot from that. And thanks for open sourcing to your framework for that. And I hope Simon Data can keep that open source for some time and maintaining it. And everyone else can kind of learn a little bit more about the SPI by checking it out and dissecting it a bit. So with that, we are concluding the Tech Track events. So wanted to play a little bit of song that's a little somber as we part ways and say goodbye for this time, and hopefully I'll see you all again next year. So this one's called Autumn Leaves. Take care, everyone.